Welcome back, Physics 30. This is part 2 of the video. So we talked about total kinetic or total mechanical energy being part of made up of kinetic energy, potential energy, and now we're going to go through this roller coaster example. So if we look at this diagram, we can kind of get an idea. Assume the height of the hill in the roller coaster seen earlier is 40 meters, and the 555 kilogram roller coaster starts from rest at the top. So that's a key thing. We're starting from rest at the top. So it's very similar to lifting that object up. All the energy is going to be potential energy. So if we look at, and it says here, what's the speed of the roller coaster at the bottom of the hill? So at the lowest point, and then at what height will it be half the speed? Take the reference as h equals 0 at the very bottom. So we could do A over here. So at start, so at the start of the hill, so we have a roller coaster, right there's where we are at the start. So ET equals EK plus EP, and of course at the start, that is 0. It's not moving at the start, it's at the highest point it'll ever be, so all of its energy will be potential energy. So all of our energy is potential energy. So ET will be able to we can calculate that by mgh. So let's see, it's a 555. Lifting it up against gravity would be positive 9.8, and 40 meters up. Okay, so if we multiply that out, we get 217,560 before rounding. Okay. And then part 2 here would be at the bottom. So if this was the funky roller coaster, right here at the bottom is where we're at now. So we have EK and no potential. I guess I could do the same thing over here. EK was equal to 0 and EP is what we got. So again, just start off like this. So ET equals EK plus EP. By the way, if you're running out of room on this page, the whole next page, there's room to write the solution. So since we're at ground level, H is going to be 0. We don't have any potential energy. So all of our energy is going to be equal to EK, 1/2 mv squared. So our total energy, yes, is 217,560 equals 1/2 of the m multiplied by v squared. So 217,560, half of 555, 277.5. So v would be equal to, so divide each side by 277. And square root, so I skipped a couple of steps there just to save on room, 28.0 meters per second is what you get halfway. All right, so part B, if I look at the next page here, part B, at what height will it be half the speed? So again, treat it as ET equals EK plus EP. Now, at the top, it's all potential. At the bottom, it's all kinetic. So any other place, you're going to have both of them. So ET equals 1/2 mv squared plus mgh. Okay. Total energy, again, is still 217,560. Mass of 555. Now, we're told when will it be half speed. So when v is equal to half, which is 14 meters per second. So 14.0 squared plus mass positive 9.8 and h. So we're solving for h in this one. So let's see how 14 squared times 555 times a half. Remember, you have to square it first. Bed mass rules. And then 555 multiplied by 9.8. All right. Let's just move this out of the way here. So subtract 54,390. I think that's what we get. Divide by 5439. Divide by 5439. H works out to be 30 meters. So when you're 30 meters off the ground, it's going to be equal to half the speed. All right, so that's how you handle that, ladies and gentlemen. And the key thing to remember, so the total energy is found by looking at all the kinetic energy, all the potential energy. And of course, at the very top of the path, we're not moving. So all the energy is potential and can be found by figuring out potential energy. At the bottom, all the energy is kinetic because you're at a height of 0. So your H will be equal to 0 for you looking for potential energy. So ET is equal to EK at the very bottom. And then, of course, somewhere in between, you have a little bit of both. So a lot of these questions involve figuring out the total energy first. Then once you know the total energy, you can figure out the rest. All right, should be able to do the assignment now, and we'll see you again.